Hi, my name is Tejashree. I'm a graduate student pursuing my master's in computer science. Today I'm going to talk to you about a research on experience requirements in video games, definition and testability by David Khalil and Philip Dweck. Software requirements is a description of software system to be developed which lay out functional as well as non-functional requirements. May include a set of cases that describe user interactions that software must provide. Whenever any software product is developed, to see whether it is working as expected and is fulfilling the designing goals, we define a set of specific requirements on which test cases are created, and we test those test cases to determine whether we are successful in our achieving the goal. In other words, test cases tells us about whether our software is functioning properly. In case of productivity softwares, since we are all aware about how we want our software to perform, what task it should perform, we know most of the specifics using which we can well describe our software. Defining requirements for such software is easier, and once the requirements are properly formed, those requirements can be tested. On testing those requirements, the result gives us clear idea whether have we met the designing goals. The softwares which are widely designed with the purpose of producing information, those softwares are known as productivity softwares. So those softwares are designed with the intent that user should be able to grasp its functioning in less period. They should be easy to learn so that user can achieve mastery in less period of time. This software has well-defined set of tasks that it should perform. For instance, Microsoft Office. In Microsoft Office, where we can say MS Word should display the input given by user through keyboard and save it. But when we talk about entertainment softwares like video games, defining the requirements for those software is not as straight in the case of productivity softwares. A simple statement like I want to build a game like Flappy Bird demands wide set of requirements, such as since it is a very simple one-tap game, a very simple user interface with simple rules, and many more which can be interpreted only after we start playing the game. What do I mean by that? In any video game, the aim of the designer is to increase user involvement in the game and to maintain and increase user interest in the game. And to achieve this, games are designed in such a way that they have a long-term learning curve. That is, when user starts playing the game over the time, he learns more and more skills. There are new difficult levels and many features which evoke curiosity and interest by challenging the game player in a joyful way. Unfortunately, the above line cannot describe critical requirements that are integral part of the design and development process. Going a little further, the statement implies the game should be something like Flappy Bird. That is, we can get some similarities from the sentences, but the sentence is all silent about what are going to be the differences. There must be something which differentiate both the games. And here I introduce that something which complicates the task of defining requirements for entertainment application and which put the entertainment application in whole different category than productivity applications. While playing a video game soccer, a player shouts, "Oh, that was a goal!" with tremendous joy with a tint of victory. Our answer lies there. The joy and the feelings which were induced by the game into the user. The games are subjective in nature, hence the requirement hold various types unlike productivity software. Productivity applications are different than entertainment applications because entertainment applications are subjective in nature. Video games, the design and development of the game is heavily influenced by human feelings. The game should be able to engulf the user at such extent that while playing FIFA, player should feel like he's a soccer player playing with a team or a well-trained shooter and terrorist while playing the game like Counter-Strikes. Using this requirement as a guidance and technique, the game playing experience can be expressed as a combination of three types of requirement: emotional requirements, gameplay requirements, which includes cognitive as well as mechanical requirements, and sensory requirements, which includes audio, video, and haptic requirements. This paperwork is based on previous work. Previous paper related to this area. Tellel et al. Introduced emotional requirements as a technique for capturing the game designer intention for emotional state induced in the player. While in other work, he has introduced cognitive requirement to help to capture cognitive challenges in the game. And finally, he proposed a model which extend these emotional and cognitive requirements to include mechanical and sensory requirements, which we are going to use. In this paper, we concentrate on cognitive requirements, mechanical requirements, and sensory requirements, since these requirements interact to define a gameplay experience. In an investigation by Dineva, explains the vital role of paper prototyping, in which design a test and test user-centered applications by rough sketches on the paper, and play testing, where testers actually plays the game and test. These factors are very important. The games are subjective in nature, hence the requirements hold various type unlike productivity softwares. Productivity applications are different than entertainment applications because of this reason. Since the design and development of video game is heavily influenced by human feelings, the game should be able to engulf the user such an extent that while playing FIFA, a player should feel like he's a soccer player. So, as always, as in the case of Counter Strike, he should feel that he's a well-trained shooter, playing in an anti-terrorist team. This guidance and techniques and the game playing experience can be expressed as a combination of three types of requirement: emotional requirement, gameplay requirement, which includes cognitive as well as mechanical requirements, and sensory requirement, which includes audio, video, and haptic requirements. This paperwork is based on previous paperworks. Kellel et al. Introduced emotional requirements as a technique to capture the game designer's intention for emotional state induced in a player, while in the other work, he has introduced cognitive requirements to help to capture cognitive challenges in a game. Finally, he proposed a model which extends these emotional and cognitive requirements to include mechanical and sensory requirements. And in this work, we are going to use this model. In this paper, we concentrate on cognitive requirements, mechanical requirements, and sensory requirements. Since these requirements interact to define a gameplay experience, we are going to use of this technique. In an investigation by Dineva, explains the vital role of paper prototyping, in which designer designs and attests user-centered application by rough sketches on the paper, and play testing, where tester actually plays the game and test. These points are very important in validation method. He further adds that balancing the elements of gameplay is most difficult and ongoing task, almost labor-consuming. Prototypes, such as paper-based prototype, can use much earlier than software prototype for user acceptance testing. Cost effectiveness: when a change occurs is significantly greater than within the software prototype. Moving further, we can also refer to work by Lee et al., which propose the use of standard notation so as to bridge the gap between user experience and feature implementation. Loefer investigated the desire for intuitive interfaces and addressed resource shortfall through the use of image schemas and image schematic metaphors, a technique that parallels our work in emotional requirement representation. Assessing compliance for soft goals such as usability is challenging. Primrose and Story used Kano categories to assign usability grades to requirements. Features and implementation of Kano model. The Kano model is a theory of product development and user satisfaction, which classifies customer requirement in five categories: a must-be quality, which is taken for granted when fulfilled, but causes dissatisfaction if not; then one-dimensional quality, same as previous, but these are spoken requirements that on which companies usually compete for for example, so for some price, for same price, some companies product gives more quantity than other company. Third one is attractive quality. The fourth one is indifferent quality, the quality which we can say neither good nor bad. And the fifth one is reverse quality. So the current work faced similar challenges, but chose to use the player scoring system to ensure that the interests of tester and players are well aligned. The aim for this research is to verify that we can capture this requirement, and on implementation, these requirements deliver expected experience to the user. In simple words, this paper is focused towards creation of testable user requirements and challenges associated with them. So we are going to create requirements and then we will design a test to check whether the implementations will satisfy the requirements. We discussed before that we define a game in terms of three dimensions: cognitive, mechanical, sensory. Keeping sensory part for the art department, we focus here on cognitive and mechanical aspects of the game. In the graph, the dotted blue line in figure 1 represents the intensity of the cognitive challenges over time. As shown, the challenges appear regularly, but this intensity grows as the player stays alive within the game. In side-scrolling game, where the player must dodge incoming obstacles, the peak represent the player avatar is coincident with the obstacle. The decreasing slope represents successfully evading the obstacle, and the tough represent the relaxation point just before the next obstacle becomes visible. So the lowest point is a relaxation point. The dashed grey line in figure 1 represents the more general dimension of mechanical difficulty. In example, it might represent the apparent velocity of the player within the world. The apparent velocity starts off slowly from zero but grows rapidly for first 15 seconds before tapering off. The orange line in figure 1 represents the combination of these dimensions. The player perceives that their velocity within the world is rapidly growing, but the challenges are not very difficult to begin with. The player is expected to learn how to control this avatar during this period and to become accustomed to how fast they are moving. As the rate of velocity change reduces, the player is presented with increasing difficult cognitive challenges that they must overcome. It is important to note the interaction between this dimension. Player focus is initially upon the environment and basic skill acquisition, but is then transitioned to focus upon skill refinement within the relatively constant environment. This combination of interactions between the dimensions provide the player with opportunity to learn how to perform within the environment and by extension to achieve ever-growing degrees of success as they learn how to survive longer within the game environment. Look and feel. Look and feel description of the gameplay experience and to translate the description into requirements that can be used by production team to deliver that intended experience. We are going to define these requirements for Lumberjack Run, a game which is more like maze games in style of Temple Run and Subway Surfers, where forward motion in the game world is out of player's control. Player has to avoid obstacles by jumping, turning left or turning right, or crawling down while running. Initial speed is 0, which gradually increases. Also, its difficulty level increases gradually. Experience requirements are requirements which describes the intended look and feel of the game, which are then used to design the game. In simple words, we can sum up the game challenges requiring following efforts. As you can see on the screen: recognition, identifying possible solution strategies, choosing a solution strategy, executing the solution strategy. Player is Player is able to jump from one lock to another lock with a vertical swipe. He can transition the facet to left or right by swiping left or right respectively. The challenges are further complicated by segmenting the lanes into individual locks, and the player is required to jump from one lock to another or fall off into the surrounding water. Medium and high difficulty levels. Each pattern can be repeated from 1 to n times, and each instance of pattern can be placed as defined, or it can be mirrored along either or both x and y axes. 3-lane pattern can also be copied to create more patterns. In other words, these patterns are placed in a game world in quasi-random manner, where a family of heuristic is applied to the output of the random number generator before choosing the next challenge pattern and the manner in which it is instantiated. Now, once we know the experience requirements, it's time to translate them into testable functional requirements. Considering one of the example as the player must remain on clear path by dodging all oncoming obstacles can be translated into a series of explicit functional requirements. Like the game must support left, right, up, down actions. The user interface for the game must provide a means for the player to indicate that they need specific action to occur. Also, we can define another functional requirement on this as there exists at least one sequence of player actions that leads to player success for a given challenge. There can be requirements for detailed specifications like about response time. That is, the response time of user interface must meet the game designer specifications, and so on. Other example, it says high difficulty cognitive challenges are only placed later in the given play session once player's speed has also substantially increased. This experience requirement was expressed by the following functional requirements, which implies player speed should start from zero, which gradually increases over the time. We can define more functional requirements as, let's say, cognitive challenge difficulty must increase with time in game. Mechanical challenge difficulty must directly correlate with cognitive challenge difficulty. So, noticing such requirements, we find that these are quite ambiguous. In requirements practice, generally requires that these terms are disambiguated before proceeding. However, the game design context is quite different. The game designer is expressing a concept that is intended to induce an emotional or experiential response. Noticing such requirements, we find that these are quite ambiguous. In requirements practice, generally requires that these terms are disambiguated before proceeding. However, the game design context is quite different. The game designer is expressing a concept that is intended to induce an emotional or other experiential response. These induced responses are the target of the noted requirement, and while these requirements could be disambiguated with qualifiers, these qualifiers would likely only apply to a specific market segment. Hence, in practice, a game may be deconceived or designed to target a given market segment, but it's common for the final target market segment to differ from the original design. That's the reason to create precise specific requirements for a game is difficult. It's too difficult to predict at early stages what can be perceived as fun. Now we move on to the development of our test plan. Since it was impractical to develop independent platform just for testing purpose, we need to test these functional requirements in actual gaming environment. But to perform the test as research, we opted for modifying the game platform into research platform. The algorithms made for this game are suppressed and new testing algorithms were created in order to perform the test so that we can vary the effects. We also had to develop remote data acquisition, a centralized collection of infrastructure, and data analysis procedure. The greatest challenge that faced was the confounding factors. Identifying the possible confounding factor is challenging, and attempting to control for those confounding factors was even more challenging. The confounding factors just player skill, where variety of players from children, casual gamers, experienced gamer, male, female, and so on. It's difficult to move forward ignoring the such factor. Hence, it was also important to involve wide set of users in our test plan. Given that the game is mainly based on player reaction, dexterity, and hand-eye coordination, these are significant confounding factors. In this game, difficulty is an interaction between cognitive challenge and mechanical challenge. We couldn't move with single aspect since we cannot be sure that even if we met functional requirement in one dimension, implies that we have met the functional requirement another dimension. To state the requirements in natural language is fine, but unfortunately it doesn't always render easy to understand the definitions for metrics. For example, the game's difficulty should increase over the time. What does that actually mean? When we play the game, we enjoy the stress that game put upon us. Also feel the sense of reward when we win or get rewards. If the score goes up slowly despite our best efforts, then we can say the game is difficult. To proceed with research further, questions are generated whose answer can guide the refinement of the game for further proceeding. For example, requirement one can be what differences were there between player performance on challenges when player perform on slower speed and when player perform at higher speed. Requirement two can be the question two can be, is there any evidence of learning effect? Did the players get better over the time? Is the learning effect constrained to single pattern, more than one pattern, all patterns? Out of 30 participants, 14 completed the regime. Upon follow-up, the one who didn't complete the regime either became bored or quit or become tired and quit. A linear increase in mechanical difficulty combined with cyclic presentation of challenges over ever increasing cognitive difficulty. Once the player reach particular game, at the particular distance in the game, the challenges are placed which are drawn from the maze pattern. We perform quantitative testing and address the challenge of measuring two dimensions with single value by partitioning the tests themselves into dimensions. Mechanical difficulty was assessed by testing the given maze pattern at two speeds, as if the player was at the start position, and then again at the game speed, as if the player was already at 800-meter mark within the game. Finally, the test group was partitioned into two subgroups, Group A and Group B. Group A was presented with each maze pattern as if they were at the start position, and then again if they were starting at 800-meter down. Group B was presented the maze pattern as if they were starting at 800 meters and then again as if they were starting at the beginning. Each run can require from more approximately 5 seconds to 2 minutes to complete. If the average run time is approximately 30 seconds and test session is targeted at 1 hour duration, then each participant should be able to complete at least 60 runs. The target test session duration constraint, that is 60 minutes, left a budget of 5 runs per challenge at each of starting condition. And after this test, the test results are as follows. That performed better at slower speed than the higher speed results. For maze 1, if we can see in the graph, the results are mixed. However, the differences are uh, less pronounced for maze 5 and maze 6 as the difficulty level increases. About death instances, the differences are less prominent in maze 5 and 6. Moving forward, maze 6 shows some learning effect at the slower speed, that is figure 7, you can see here. A small learning effect may be occurring in maze 4 at higher speed, especially at the last run. This test was unable to gather sufficient data to properly guide our designing efforts. Efforts can be taken to next step by more recruitment of participants to gather more data, to receive the desired difficulty assessment information and apply the knowledge to our design efforts. This experience demonstrates that it is possible to evolve an experience requirement to set of testable functional requirement. Nevertheless, practically validating the requirements in system as complex as video game is an intimidating effort. In a remainder of this section, we briefly summarize what we learned and attempt to identify specific challenges that practitioners may face in their own efforts. So in game design, division diversion in game design may seem, by all accounts, to be specifically appointed efforts contrasted with the productivity software design. And this point of view is supported much of the time, in much of the cases. However, it is possible to be very deliberate in many aspects of the design effort, predominantly in the game mechanics, which can use to develop mathematical abstractions of the user experience for supporting the design of experimental efforts. So, in short, these efforts can help the designer to understand what the game is. Experience requirements work well to convey substantial information in very compact manner, information that can be challenging to verbalize. Converting experience requirements into testable functional requirements can be difficult and can lead to much larger set of requirements than anticipated. Fortunately, these resulting functional requirements can be interpreted within the context of experience requirements, which increases the probability of successful communication. Experimental design is important to understand the dimensional complexity and apply appropriate design of experimental techniques to compensate. One issue that we noted that it has the potential to complicate experimental design is short-term memory bias during the gameplay. Since players tend to learn successful patterns which can be taken into account while designing the game. Practitioner may expect that substantial changes to game engine may be required to accommodate the necessary data acquisition. Confounding factors, as mentioned earlier, the effect of confounding factor is there on both type of softwares, productivity software as well as on entertainment softwares, but it affects differently since the design intent of both the software are different. This effect can be used positively in order to make the game playable. Games are high-dimensional specs that could require very large data sets to ensure the validity across the combinations of dimensions. So practitioners should do their utmost to identify dimensions that are important. If they need to identify casualty and just not the correlation within the practical budgetary constraint. Moving forward, playing game is learning experience. Player must be able to learn quickly enough to feel validated, yet not so quickly that they feel the game is too bored or too boring or easily can be easily mastered. So these factors are need to take into consideration while designing the game. Now moving forward to tester profiling, comparing result across a tester is meaningless without appropriate contextual information, such as their experience level and their physical abilities, which encourage us to select the tester set properly. So since it doesn't make any sense to if the game is designed for children, let's say, then bringing in the adult tester is of no point. Now, moving forward, test motivation. Maintaining player interest during the test was much more challenging than anticipated. We just saw that 14 only 14 participant out of 30 completed the test. So it is important to remember that these are symptoms of cognitive exhaustion and physical exhaustion, respectively. This feedback implies that it may be necessary to employ more study participants with reduced number of runs. These issues are important to notice since the issues can easily tell us flaws in our game or our design that can be improved in order to achieve success. From this research, it feels comfortable in asserting that the techniques and their caveats are likely to support generalization, but more work is necessary to be more definitive. Now, for future work, experimental methodologies and design of experiment guidance is always welcome, which is said by et al. Valen et al. Current work provide guidance for many scenarios, but doesn't provide significant guidance for multidimensional, non-functional scenarios, such as validating the intended user experience. So there is ample opportunity to develop the new techniques and method for this. Most of the guidance assumes homogeneous population, but the game domain is displays significant heterogeneity of subject, of platforms, of performance, while identifies learning as a threat to validity. It doesn't provide explicit guidance to either minimize or explicitly measure learning effects. Learning effects are a significant threat in the current work, and there is significant opportunity for future work in this area. Controlling for confounding factor may be difficult, impractical, or perhaps even impossible. Testing may require changes to the game engine, and translating these results into practitioner guidance can be difficult. Validating the results changes can also be difficult and expensive. Players learn while playing the game, and this shifting performance baseline make it difficult to interpret test results. Gathering sufficient data to be able to accommodate learning effects, which in turn suggests more participant and more tests. So it is very important to develop such test plan where participant won't get bored or tired, or we could be able to gather more and more data. This work didn't address quantitative testing of experience requirements in this work. Our test population was too small to make the feedback meaningful as anything other than anecdotal evidence. So there are significant opportunities for future work in this area. Thank you so much.